Welcome to today's episode of Book Bites, the podcast where we explore the deeper meanings and hidden narratives behind some of the world's most beloved books. I'm your host, Layla, and today's episode of Book Bites, where we dive deep into some of the most fascinating stories that have shaped humanity. In this special three-part series, we'll be exploring Stephen Oppenheimer's book, Out of Eden, a compelling exploration of the origins of modern humans and how we came to be the species we are today. In the first segment, we'll unravel Oppenheimer's argument that the human story is far more complex than traditional narratives have told us. We'll trace our roots to Africa, discover the movement of our ancestors, and learn how scientific evidence, from genetics to archaeology, has redefined our understanding of where we come from. So, sit back, relax, and let's dive into the incredible journey of human migration, as seen through the lens of Out of Eden. The story of humanity begins with a small group of humans in Africa. For centuries, the story of our origins was limited to a simplistic narrative. Humanity began as a small, scattered group of individuals, perhaps around 100,000 to 200,000 years ago. We evolved, spread out across the globe, and the rest is history. However, Stephen Oppenheimer challenges this narrative in Out of Eden with new perspectives and a wealth of scientific evidence that has emerged in the last few decades. Oppenheimer's book is not just a simple retelling of the human migration story. Instead, it's an attempt to rethink our origins, to reinterpret the evidence in a way that questions the widely accepted out-of-Africa model of human migration. The out-of-Africa model suggests that modern humans, Homo sapiens, originated in Africa and then dispersed across the globe, replacing or interbreeding with other human species like Neanderthals and Denisovans. Oppenheimer, however, pushes us to consider how migration was not just a one-off event, but a gradual and far-reaching process that took place over thousands of years. At the heart of Oppenheimer's thesis is a rethinking of what Africa really means in the story of humanity. Traditionally, when we hear the phrase out of Africa, we picture a singular point in time when humans began to leave their African homeland. Oppenheimer presents a more nuanced perspective, one where the migrations were more fluid, and the out-of-Africa process was not just a singular event, but a lengthy series of movements that occurred over tens of thousands of years. The genesis of human evolution in Africa. Oppenheimer begins by taking us back to the roots of humanity, around 200,000 years ago. The picture he paints is one of a diverse and evolving African landscape, where early humans began to adapt to a changing environment. It's important to note that, contrary to early assumptions, the origins of Homo sapiens were not as singular as once thought. The initial humans who emerged were not just one small group, but rather part of a larger, interconnected population of early humans across Africa. The environment, primarily the varied climates and ecosystems, played a major role in shaping early human populations. Oppenheimer draws attention to the fact that genetic studies suggest humans were not isolated. Instead, we see signs of genetic mixing long before the large-scale migrations took place. These populations were spread across vast areas of Africa, and over time, they became increasingly genetically distinct due to regional environments and climatic shifts. What we know today, largely through genetic research, is that Africa was not a simple, unified place. It was a dynamic, changing world, with distinct regions, each contributing uniquely to the genetic makeup of modern humans. This African diversity sets the stage for a pivotal moment in human evolution, the point where our ancestors began to develop traits that would separate them from other species. According to Oppenheimer, the migration and dispersal of Homo sapiens across the African continent helped shape our unique characteristics, traits like larger brains, more complex social structures, and greater adaptability to different environments. The power of genetics and the mitochondrial Eve hypothesis. One of the key components of Oppenheimer's argument is the use of genetic evidence. For many years, the mitochondrial Eve hypothesis was central to the out-of-Africa theory. This hypothesis suggested that all modern humans share a common ancestor in Africa, identified through mitochondrial DNA. Mitochondrial DNA, passed down from mother to child, provides a clearer picture of human ancestry and is much less subject to the recombination that affects nuclear DNA. It was thought that all humans could trace their lineage back to a single Eve, who lived around 150,000 to 200,000 years ago. Oppenheimer, however, emphasizes that while mitochondrial DNA is invaluable for tracing maternal ancestry, it provides only a partial view of the picture. He argues that focusing solely on this gene ignores the wealth of information in our entire genetic makeup. By expanding the genetic analysis to include the Y chromosome and autosomal DNA, which come from both parents, a clearer and more complex story begins to emerge. Through the analysis of mitochondrial DNA, Oppenheimer presents compelling evidence that suggests that early Homo sapiens did indeed emerge in East Africa. However, unlike previous interpretations that focused on a singular, sudden exodus, Oppenheimer paints a picture of an extended migration process, one that occurred in waves and through different routes over tens of thousands of years. The idea of out of Africa being an ongoing, long-term process becomes central to his theory. The southern route, coastal migration. One of the most exciting aspects of Out of Eden is Oppenheimer's detailed exploration of migration routes. While the classic model of human migration largely focused on an inland route out of Africa, Oppenheimer introduces the idea that humans likely followed a coastal route. This southern route took them along the edge of Africa, following the coastline from East Africa all the way to the Arabian Peninsula, and from there into Southeast Asia and beyond. The southern route theory has gained traction in recent years, especially with evidence suggesting that early humans might have had a preference for coastlines. Coastal areas would have provided more consistent resources, such as fish and marine life, than the inland areas, which were subject to the harsh conditions of Africa's interior. By moving along the coast, early humans would have had access to abundant food and water, making it an ideal pathway for migration. Moreover, recent archaeological findings suggest that early human populations were far more capable of navigating the seas than previously imagined. Tools, remnants of settlements, and even evidence of sea-based migrations reinforce the idea that humans were not just land-based wanderers, but oceanic explorers as well. Coastal migration allowed humans to spread more rapidly, using islands as stepping stones and adapting to a variety of environments along the way. The role of climate in shaping our ancestors' movements. Oppenheimer also emphasizes the importance of climate in shaping human migration patterns. The dramatic shifts in climate during the Pleistocene epoch, characterized by alternating ice ages and warmer periods, had profound effects on human populations. These climate changes created a more dynamic environment, pushing populations to move, adapt, and sometimes even evolve in new ways. For instance, during glacial periods, the Sahara Desert, now a vast arid expanse, was much wetter and more hospitable. Evidence shows that early human populations may have thrived in this region before the climate changed, forcing them to migrate. Conversely, periods of warming caused the desert to expand, creating a barrier for human movement. Thus, humans were continuously responding to the ever-changing climate in Africa, shaping not only their movements, but also their genetic evolution. Oppenheimer's meticulous analysis of genetic evidence, climate data, and archaeological findings allows us to better appreciate the intricate history of humanity. Africa was not merely the birthplace of Homo sapiens, it was the cradle of an evolving human story that stretches across time and geography, weaving together a tapestry of diversity, adaptation, and survival. The Great Migration from Africa to the world. Imagine it. Tens of thousands of years ago, early Homo sapiens began their epic journey out of Africa, following coastal routes along the shores of the continent and spreading into regions that were once thought to be uninhabitable. For many years, the traditional view of this migration painted a picture of a single wave of humans leaving Africa, following one clear path across the globe. But as Stephen Oppenheimer argues in Out of Eden, the process was far more complex, involving multiple waves, routes, and different periods of migration. Let's begin with the most well-known route, the southern coastal route, and trace how early humans spread across the world. The southern coastal route, following the shores of Africa. The southern coastal route theory is one of the most revolutionary ideas in Oppenheimer's Out of Eden. For decades, the prevailing view of human migration focused on an inland route, with early Homo sapiens leaving Africa through the Sinai Peninsula and heading toward the Middle East, Europe, and Asia. However, Oppenheimer introduces compelling evidence that our ancestors, instead of heading inland, likely followed the coastlines of Africa. This southern route would have taken them along the edges of Africa, starting from East Africa, where modern humans first evolved, along the eastern coast, past the southern tip of Africa, and then up the western coast, crossing over into Arabia and Southeast Asia. Why the coastline? Well, there are several advantages to traveling by sea. Coastal areas are rich in resources like fish, shellfish, and other marine life. This would have provided a stable food supply for early human populations, allowing them to thrive in an environment that might have been too harsh or barren inland. The coastlines also offer a more direct path to other land masses, and with the right tools and boats, it's entirely plausible that early humans could have navigated the seas, something that archaeological discoveries in places like Australia and Southeast Asia seem to confirm. Recent findings suggest that humans could have been in these coastal regions as far back as 50,000 to 60,000 years ago. Archaeological evidence from places like the island of Flores in Indonesia shows tools and fossils that challenge earlier theories about the timing and routes of human migration. By 45,000 years ago, humans had made it to Australia, likely using these coastal routes. This early migration, Oppenheimer suggests, was not a random series of movements, but part of a deliberate effort to explore and occupy new regions. Crossing into the Middle East and beyond, the land bridges. But the coastal route wasn't the only pathway. Another critical part of the migration story is the use of land bridges, which connected continents during periods of lower sea levels. As the ice ages came and went, sea levels fluctuated, exposing land bridges that enabled humans to cross from one landmass to another. Perhaps the most famous of these land bridges is the one that connected Siberia to Alaska, allowing humans to enter the Americas. But before that, land bridges also facilitated human movement from Africa into Europe, Asia, and the Middle East. As the glaciers advanced and retreated, vast areas of the world were reshaped. During warmer periods, when ice melted, sea levels fell dramatically, exposing the land between Asia and North America. Around 60,000 years ago, this land bridge, known as Beringia, formed between Siberia and Alaska. It created a corridor that humans could use to migrate into the Americas, eventually populating the continent. Meanwhile, in the Middle East, the land bridge between Africa and Asia provided a route into the Levant and beyond. The Strait of Hormuz, which today separates the Persian Gulf from the Arabian Sea, was once much narrower or even completely dry, allowing humans to move into what is now Iran, Iraq, and further into Asia. The migration into the Middle East was crucial for the dispersal of Homo sapiens. It's here that we begin to see the meeting of different human species, most notably the interaction with Neanderthals in Europe and Denisovans in Asia. But Oppenheimer argues that this was not a simple story of replacement, as was once thought. Instead, humans interbred with these species, leaving traces of Neanderthal and Denisovan DNA in our genomes today. Oppenheimer suggests that the process was not a clear-cut invasion or replacement, but rather a mixing of genes and cultures. This interaction between Homo sapiens and other human species is essential to understanding our genetic makeup. Today, we carry Neanderthal genes, and in some populations, Denisovan DNA is still present, reminders of our shared past and the incredible journey of migration that brought us to where we are today. The journey to the east, Southeast Asia, and Australia. One of the most fascinating aspects of human migration, as explored by Oppenheimer, is the movement of our ancestors eastward into Southeast Asia and Australia. By around 50,000 years ago, modern humans had reached the vast archipelagos of Southeast Asia, and by 45,000 years ago, they had crossed into Australia. This was no easy feat, as the distance and the environment were both daunting. The route into Australia is particularly notable. Early humans would have had to navigate through a series of islands, crossing narrow stretches of water to get there. Evidence of sophisticated tools, including fishing equipment and ceremonial items, suggests that these early humans were not only skilled navigators, but also social and culturally complex. The migration to Australia is often regarded as one of humanity's earliest major maritime achievements. In Southeast Asia, our ancestors adapted to new environments and encountered new challenges. They interacted with other species, such as the enigmatic Denisovans, whose DNA is found in modern populations across the region. The evidence of these interactions has reshaped our understanding of human history, suggesting that migration was not a simple one-way journey, but a complex and multi-layered process. The legacy of the Great Migration: genetic evidence. As early Homo sapiens spread across the globe, they left behind genetic markers, footprints in the DNA that have been uncovered by modern scientists. Oppenheimer's work highlights how these genetic traces reveal not just the paths our ancestors took, but also the interaction between different human species. Through the study of mitochondrial DNA, the Y chromosome, and autosomal DNA, scientists have pieced together a clearer map of human migration. What is particularly fascinating is how genetic evidence shows a much more complex picture than previously thought. It's not just about tracing one clear line of descent, it's about understanding how populations mixed, migrated, and adapted over time. Oppenheimer emphasizes that genetic diversity is the result of these interactions and migrations. Modern humans, despite their outward differences, share a deeply interconnected genetic history. Legacy of the migrations: the genetic and cultural impact. When we think of human history, we often imagine a linear progression from ancient times to the modern world. We think of civilizations rising and falling, cultures evolving, and the slow march of technological progress. But what if we told you that much of what makes us human, the very essence of our genetic makeup, our behavior, and our social structures, was shaped long before the rise of cities and empires? Stephen Oppenheimer's Out of Eden invites us to reconsider the deeper roots of human civilization, pointing to the migrations of our ancestors and their genetic legacies as foundational to who we are today. In this final segment, we explore how these migrations influenced everything from our physical characteristics to our cultural practices and social behaviors. The genetic legacy of the early migrations. We learned that early Homo sapiens didn't just leave Africa in a singular wave. They spread across the globe over tens of thousands of years, following coastal routes, land bridges, and adapting to a wide variety of environments. But what's even more fascinating is how these migrations shaped our genetic diversity. Oppenheimer uses genetic evidence, especially from mitochondrial DNA, the Y chromosome, and autosomal markers, to show how these early movements laid the groundwork for the genetic differences we see today across human populations. One of the key insights from Out of Eden is that the migrations of our ancestors weren't isolated events. As humans moved, they interacted with other populations and even other species. Early Homo sapiens didn't just replace Neanderthals or Denisovans, they interbred with them. These interactions left a lasting imprint on the human genome, and Oppenheimer emphasizes that much of our genetic diversity today can be traced back to these ancient encounters. In fact, Oppenheimer points out that modern non-African populations carry between 1% to 4% Neanderthal DNA, while populations in Southeast Asia and Oceania also have traces of Denisovan ancestry. This interbreeding between different human species is a fundamental part of our evolutionary history. It highlights that the story of human migration was not just one of dispersal and colonization, but of genetic mixing, collaboration, and shared survival. These genetic exchanges help to shape our adaptability and resilience in new environments. Moreover, the spread of Homo sapiens was not just about population size or genetic mixing, it was also about the introduction of new behaviors and technologies. Oppenheimer argues that as humans moved across the globe, they carried with them innovations in toolmaking, social organization, and cultural practices. These shared innovations provided the foundation for the development of complex societies. The rise of cultural diversity. One of the most intriguing aspects of Oppenheimer's work is the connection between early migrations and the rise of cultural diversity. As Homo sapiens spread across the world, they encountered different environments, resources, and challenges. These factors, combined with the genetic diversity we've already discussed, gave rise to distinct cultural practices, social structures, and ways of life. Oppenheimer suggests that the cultural differences we see across human societies today, ranging from language and religion to art and technology, are the products of these ancient migrations and the way early humans adapted to their new surroundings. For instance, the development of agriculture in the Fertile Crescent around 12,000 years ago was a direct result of the knowledge passed down from early human groups who had already developed tools and techniques for managing their environment. The arrival of agriculture marked a dramatic shift in human society. It allowed for the rise of permanent settlements, the growth of population densities, and the development of early cities. But this revolution didn't happen in isolation. Oppenheimer highlights the diffusion of agricultural knowledge across different regions, often facilitated by the interactions of various human groups that had been traveling and exchanging ideas for millennia. Similarly, the development of language and social systems can be traced back to the migrations of early Homo sapiens. As they moved across the globe, early humans developed diverse languages and systems of communication. These languages didn't emerge out of nowhere. They were shaped by the environment, the social needs of communities, and the continuous exchange of ideas between different groups. The cultural practices of early human populations were also influenced by the migrations and the interactions that occurred along the way. As different human species coexisted in various regions, they shared knowledge, skills, and traditions that became embedded in the cultural fabric of emerging societies. These exchanges helped to foster the rise of complex social structures and the eventual development of religions, art, and technology. Cultural and genetic interactions, the case of the Denisovans and Neanderthals. One of the most fascinating revelations from Oppenheimer's Out of Eden is the story of the Denisovans and Neanderthals, two ancient human species with whom Homo sapiens interbred. These species didn't disappear abruptly. Instead, their genetic legacies live on in us today. Oppenheimer examines how the interactions between Homo sapiens and these species influence not only our genetics, but also our cultural development. For example, genetic evidence suggests that certain populations, particularly in East Asia and Oceania, have inherited genes from the Denisovans that may have played a role in adapting to high altitudes. In the Himalayas, certain Tibetan populations carry a genetic variant from the Denisovans that helps them thrive in low-oxygen environments. This example underscores how interbreeding with other human species may have provided adaptive advantages, helping populations to survive and thrive in diverse environments. Similarly, the Neanderthal legacy can be found in various traits, from immune system function to skin and hair characteristics. These contributions from Neanderthals and Denisovans were not just genetic relics. They were part of the evolutionary process that allowed early humans to adapt to new challenges and environments. Oppenheimer suggests that these interactions were integral to the survival and success of Homo sapiens, showing that our evolutionary journey was far from a solitary one. The global impact of early migrations, from isolation to connection. Oppenheimer's work also highlights how the early migrations of Homo sapiens set the stage for the eventual rise of interconnected global societies. As humans spread across the globe, they not only exchanged genetic material, but also ideas, technologies, and innovations. Over time, these isolated populations began to connect through trade, exploration, and the gradual development of communication systems. The genetic diversity we see today is a direct result of these early human movements. But beyond genetics, these migrations also laid the groundwork for the development of the world's great civilizations. From the rise of agriculture in the Near East to the development of writing in Mesopotamia, from the establishment of city-states in Africa to the great empires of China and India, the legacy of human migration is everywhere. As trade routes expanded and civilizations grew, the spread of ideas, technologies, and religions created a global network of interconnected societies. The Silk Road, the trans-Saharan trade routes, and maritime routes across the Indian Ocean allowed for the exchange of goods, knowledge, and culture. The rise of cities and the spread of agricultural techniques, writing systems, and social institutions were all shaped by the migration of humans and the interactions between diverse populations. The final reflection: understanding our shared history. As we conclude this summary, it's clear that Out of Eden offers a profound reimagining of human history. Through the lens of genetic evidence, archaeological discoveries, and the study of human migration, Oppenheimer helps us see that the story of humanity is far more interconnected and complex than we once believed. The migrations of our ancestors were not just about survival and settlement. They were about adaptation, collaboration, and the exchange of ideas and genes. These movements left lasting legacies, shaping not only our genetic makeup, but also our cultures, behaviors, and societies. Oppenheimer's work challenges us to rethink the narrative of human history, moving beyond the traditional view of isolated civilizations and recognizing the deep connections that have always existed between human populations. We are all part of a shared story, shaped by the migrations of our ancestors, the exchange of ideas, and the blending of cultures. Thank you for joining us. We hope this exploration has deepened your understanding of the incredible journey of our species and how the migrations of our ancestors continue to shape who we are today. Stay curious and keep exploring the history of us. Until next time, keep searching for the stories that connect us all. This is the history of us.